Okay, in this video we will work through problem 2 of lab 1, and problem 2 has us solving some algebra problems similar to the algebra that we did to calculate that internal angle, that other internal angle in problem 1, but a little bit more complicated algebra. In each one of these cases down here, we're given an equation that's a function of x, and we're asked to solve for the numerical value of x. So take this equation here, for example, rearrange it to solve for the numerical value of x, given these values up here of these constants a, b, and c that have the same values for those constants in any one of these three equations that they appear in there. Okay, what you want to do here for each one of these is symbolically rearrange each one of these equations. Symbolically means just work with the symbols. Don't punch in the numbers for a, b, and c yet. We'll do that at the end. But symbolically rearrange each one of these equations so that you get x by itself on one side of these equations. It doesn't matter which side. And then the other side is the formula that you're going to punch into here in Excel to calculate the value for x. So just like we did in the first problem, you're not calculating the numerical result somewhere else and just entering it in here like a number. You're going to determine the formula here for calculating the value of x, and then you're actually going to enter that formula and do that calculation here in these three yellow boxes in problem 2 in the Excel sheet here. So how do we actually do this? Rearrange these equations to solve for x. Let's go to my notebook here. And my first equation said that 16.7 equals a times x squared plus 0.5b, and I'm going to make that b over 2 here. Okay, and I want to get x by itself on one of these sides of this equation, doesn't matter which side. So first thing I'm going to do is I'm going to subtract b over 2 from both sides. And so that gets me 16.7 minus b over 2 equals ax squared then if I divide both sides by a, then I've got x squared by itself. And then if I take the square root of both sides, I have that x equals the square root of 16.7 minus b over 2 on the top divided by a on the bottom. Okay, so that's my equation for rearranging this original equation algebraically to solve for x, or to isolate x by itself on one side of this equation. So then I'm going to go to my Excel sheet, and I'm going to go to where it asks me to enter in the value, or to solve for x for my first equation here. And I'm going to say x equals square root of 16.7 minus b over 2 on the top divided by a on the bottom, and then close out my function there. And I get that x is about 1.9 or so. And we can check that by entering my right-hand side of my original equation up here. If I do a times x squared plus b over 2, I should get 16.7. And I do get 16.7. Okay, let's take a little bit closer look at this formula I entered in here. I said it's the square root, and then I did 2 left parentheses, 16.7 minus b over 2, and then a right parenthesis divided by divided by a, and then another right parenthesis. So what's going on with all those parentheses? Depending on your version of Excel, it may or may not match up your parentheses here with colors here. When it's got the colors there, the red one is saying this red left parenthesis and this red right parenthesis, those are a pair of parentheses, and this white one here and this white one here on the end, those are a pair of parentheses. So parentheses in formulas like this always have a left one and a right one. There's never a case where you would write just a left one or just the right one. The white ones here, those are the start and end of that square root function. And so then whatever I enter inside those white parentheses, that's the argument that I'm entering into the square root function. So that's saying I want the square root of everything that's inside these two white parentheses here. Okay, and so that's why those are looking like that in that formula, because here I wanted the square root of everything there. And so I put everything, that whole left-hand side there of that formula, inside my square root function here. This other set of parentheses here, the red one there, so the red left parenthesis and the red right parenthesis there, is saying my numerator of my fraction here, the top part of my fraction here, is 16.7 minus b over 2. Okay? If I didn't have that, let's just say I didn't have those parentheses there, what do I get? Then I get a very different result. I got 4.1 instead of 1.9. But if I don't have those parentheses there, then it's like I'm saying, I want you to give me the square root of 16.7 minus b divided by 2 divided by a. Okay, and that's not what I want. I don't want 16.7 minus the quantity b over 2 over a. I want 16.7 minus b over 2, so whatever that is, and then I want to divide whatever that is by a. So I have to tell Excel, I want you to first calculate 16.7 minus b over 2, and so the parentheses are isolating that part, and then I want you to divide that whole thing, whatever it is, by a. Okay? So that's why those two sets of parentheses are in there, and why you'll need those red parentheses in there to get this, to give you the answer that you want. Okay, on to my second equation, which was 5.4 equals a times the tangent of cx minus b. And let's clear out my workbook here. And once again, I'm going to write everything out here. So 5.4 equals a times the tangent of cx minus b. And once again, I want to solve this equation for x. So how do I do that? I'm first going to divide both sides by a. And then I want to get rid of my tangent there, so I'm going to take the inverse tangent, or arctangent, of both sides. Equals cx minus b. Then I'm going to add b to both sides. This will take me a while to draw it here on my trackpad, sorry. A little slow. Over a plus b equals cx. And then divide both sides by c. And we once again have x by itself. So I've got that x equals the inverse tangent of 5.4 over a plus b, and then that whole thing divided by c. So let's enter that in my spreadsheet here. Got that x equals inverse tangent of 5.4 over a, and then that inverse tangent plus the value of b, and then I want to divide that whole thing, everything I've done so far, by the value of c. So I'm going to collect everything there in parentheses and divide that whole thing by c. And I get that x is negative 3.06 or so. Okay. Now, you saw me add this set of parentheses here, that set of white parentheses, where I basically take everything except for the c there and put it into parentheses. Why did I do that? If I don't have those parentheses there, I would, you can see, get a different answer. This time it's just a slightly different answer, but still a different answer. And what is it saying without those parentheses? That's like saying I want the inverse tangent of 5.4 over a plus the quantity b divided by c. Okay? And I don't want to divide just b by c. I want to divide everything here, this whole numerator, by c. So that means in the syntax of Excel, I've got to collect everything here in parentheses so that Excel knows to do all these calculations first and then divide the whole thing by c there. Okay, so let's put my parentheses there to collect those together. And I'm back to the 3.06 or so. And again, I can check this. I can repeat my original equation. Which said a times the tangent of cx minus b. And let's see if I get 5.4 when I do that with my value of x I calculated there. So a times the tangent of c times x minus b. And I again got the 5.4 that I was expecting. So this is a good thing to do on problems like this when you calculate a value for x and you're not sure if you did the algebra here right, and you're not sure if you transcribed it correctly here into the language of Excel. Just repeat the calculation on the right-hand side that the original equation had and see if you get the value that the original equation had on the left-hand side. If you did it right, both in terms of setting up the algebra and transcribing it correctly into the language of Excel here, then you should get the exact value that you got, or that you originally started with there on that left-hand side. So good kind of sanity check to do here if you're not sure with your answers here for problems like this. Okay, last one for problem 2 here is 8.75 equals a minus b times square root of cx. So let's clear things out here. Probably a way to do this with a button press or something, but I think it's kind of fun to erase it manually there. Okay, so 8.75 equals a minus b times square root of cx. So a minus b square root of c times x. And I again want to algebraically rearrange this equation to get x by itself. So I'm going to subtract a from both sides. That gives me 8.75 minus a equals negative b square root cx. Then I'm going to divide both sides by negative b. And that gets me square root of cx by itself. Then I'm going to square both sides. Let me move my equals sign here to make it a little more clean. Then I'm going to square both sides to get rid of that square root on the right-hand side. And then lastly, to get x by itself, I'm going to divide both sides by c. Okay. So I've got x equals 8.75 minus a, that whole thing divided by negative b, that whole thing squared, and then that whole thing squared divided by c. So let's enter this one into Excel here. So I've got 8.75 minus a, and then I want to collect that together in parentheses and divide it by the negation of b. Okay. And then I want to take that whole thing, the top and the bottom, and square it. And then that whole thing that was squared, I want to collect all that together and divide it by c. And get about 6.45. And let's do a check there again. On the original right-hand side, we had a minus b times the square root of c times x. So a minus b times the square root of c times x. I should get 8.75, and I do get 8.75. Okay, what about my significant digits here? You generally want to match your significant digits when you're doing algebra here to the significant digits that are present in the numbers that you're working with. So in my first equation here, I've got a 16.7 there, so I've got one decimal place, and then I'm working with a and b, which both have one decimal place, so I should probably express x here also with one decimal place. So let's make that one decimal place instead of 8 or whatever it's got there. Okay, second equation, I'm working with 5.4, which has one decimal place. I'm using a and b and c. A and b have one decimal place, c has two, but generally you default to using however many decimal places is the fewest of whatever number that you're working with. So again, here on this one, let's set that to one decimal place. Okay. And then same deal here on C. I've got a 8.75 there with two decimal places, and I've got a C with two decimal places, but I'm also working with A and B, which only had one, and so let's set this to just have one. Okay, and that is it for problem number 2.